You are getting recorded, so don't say mean things. You could come in here. Well, yeah, but you can still come in here. Oh, you need to come in and actually do something. The other day you came just to sit. So what did you need to do? You were going to do corrections for that first quiz? Sorry, I had to go put water and drinks in the session. That's my bad. Come tomorrow, okay? If we're here tomorrow. Maybe. Maybe not.
What are the odds?
No. Quarter said 50-50. I mean, quarter's pretty good at this. So that's pretty decent, 50% chance. That's better than like 25%. Okay, so yesterday we talked specifically about, well, we introduced sequences. We talked about a couple of different types. We talked about finite versus infinite. What's the big thing that you can look at when you have a sequence written out that will distinguish an infinite versus a finite? Yeah, it's literally the dots. Dot, dot, dot. The dot, dot, dot will tell you that this sequence is going to just do what? It's just going to keep going. So that's an infinite sequence. So we talked about that. We talked about how you always name your first term what? A sub 1, okay? We also talked about how sequences, every time you have a sequence, it actually can be represented by two numbers. Remember that? We can look at it like a table. In fact, we're going to see that today. But the first value, your domain, we said is your term what? Starts with an N. Ends in number. Yeah, it's your term number.
What is that little E thing on?
Oh, that's what we're doing tomorrow. If we're here. If we're here.
Why do people complain?
Because there's supposed to be some stuff that comes in this evening from 2 o'clock to 6 o'clock. All right, anyways, let's get back to this. So your domain is your term number. Your range, your Y, is your term, starts with a V, term values. So like, for example, the first term equals this. So every number, or every number in your sequence, every term in your sequence can be defined by two things. The term number and the term values. Yes, no? Yeah, just come up here. There's these papers that are right up front. Okay, so then that led us to the main thing that you guys did for homework, and that was this thing called recursive formulas. Recursive formulas, I tried to tell you guys, were dependent type of equations. What do I mean by dependent? That's right. You can't find a term unless you have the term before. And sometimes you can't find a term unless you have multiple terms before. Like number 6 that you guys were going to try last night. So recursive, we said, is dependent in that it calls on your previous term. What did I say you write in your equation that will always call on your previous term? A sub n minus 1. A sub n minus 1 is your previous term. Brady, what's your previous term?
A sub minus 1.
A sub n minus 1. A sub n minus 1 calls on your previous term.
A sub.
Sub, like it's down low. Like instead of it being an exponent up here, it's a sub, so it's down low.
Oh.
Okay? So A sub n minus 1 is what we would call our previous term. And then it takes that and it makes some type of change. Sometimes it's multiple things. Sometimes it's one thing. But it makes some type of change. Okay? So that's what we did yesterday. And you guys were supposed to find the first 5 terms on numbers 1 through 4. Here they are. Check those out. That should have been pretty easy. Number 4 was pretty easy because they gave you the first 2 terms. You only had to find 3. So, any questions on 1, 2, 3, and 4? Do it.
Are they gonna represent these equations like in a graph?
No. That's where we're going today. explicit formulas. Those are the ones that you can represent with a graph. So great question. That's what we're going through. That's where we're headed today. These recursive ones, you can't. I can't type a sub n minus 1 into the equation, and therefore, since I need the previous term to give me my next one, I can't calculate it. See? So that's a great question. Good, like great thinking. Thinking outside the box, Jacob. I like it. Now, I'm going to go to number 5. Number 5 was not too bad, right? You notice every time it was going up by 5. So we take our previous term and we add 5 to it. So when I write my equation, I have to tell people what? I have to tell them my first term. If you don't tell them the first term, they don't know what you're dealing with. So you have to say, hey, a sub 1 equals 7. Now, from this point forward, to find every value, a sub n, you've got to take the previous term. Brady, what do we call the previous term? Close. A sub n minus 1. And then you make that change, plus 5. Okay? So that's the equation. I don't know, some people did not see that this little section also asks you to find a sub 7. So a sub 7 on this problem was 37. If you didn't see that, no sweat, write it down now. Because I'm not checking this today, but I will check 1 through 14 tomorrow. So this is included in the assignment that I'll be checking tomorrow. This will be the intro to sequences. Yes, yeah, you can already know that. That'll be what's due tomorrow. What did you say? That's number 5. All right, here's number 6. How many guys got it? Just curious. How many tried it? Like really wrote something down in your paper? Just a handful of you? Okay, here it is. I told you the little one little secret. You had to have 2 previous terms, right? So you had to have a sub n minus 1 and a sub n minus 2. So what happened every time was it took your first term and it added it to 2 times the second term. Look, if I took 2 and I added it to 2 times 3, what is 2 times 3? What's 2 plus 6? See, that gave me 8. And then the next one, if I took 3 and I added it to 2 times 8, 16, what's 3 plus 16? There you go. So that's what happens. We had to take the previous term, or the first term, which is a sub n minus 2, and we had to take the one right before it, a sub n minus 1, and you had to multiply it by 2. And then add them together. Now, I kind of compacted that. So here's the actual equation. And because it took me needing the first 2 terms, I had to define the first 2 terms. A sub 1 equals 2. A sub 2 equals 3. And now from this point on, a sub 1, or a sub n, will equal a sub n minus 2. That's 2 terms ago, plus 2 times a sub n minus 1.
Doesn't matter which way you would write that.
No. If you mean this, if you mean you wrote a sub n equals 2 times a sub n minus 1 plus a sub n minus 2, that's perfectly fine too. No, that's just taking your previous term and multiplying by 2 first, and then adding the one that was previous to that. So it's the same thing. Same thing. So either of those equations would be 100% perfect. Okay? And in fact, that's just a, what is that called? When A plus B is the same thing as B plus A? What's that called? Is that transitive property? Transitive? A plus B equals B plus A? Is that transitive property? Y'all remember all that?
No.
Transitive. I think it's transitive property. So yeah, it's the same thing. 2 times a sub n minus 1. Commutative? Okay. You're probably right. It's not associative property, for sure. I actually think you might be right.
I was the one that said that. You just took it.
Oh, okay.
No, she did.
Yeah, I think you might be right. I think it might be commutative property. Maybe. Yeah, maybe. So I've forgotten, but I think you might be right. Good job. Good job, Brady. Way to come up with that answer. You plagiarized her. She's going to sue you now. All right. Now, everybody good with those 6? I know 6 was kind of challenging. Sometimes it's nice to kind of step outside your comfort zone and think a little bit. So hopefully you guys, you did that. You at least tried it. That's all I really wanted. I wanted you to try it. So today we're moving on. We're moving on to explicit formulas. Okay? So listen to me. This is very, very important. You listening? Put your phone away. And listen. Recursive formulas, they call on the previous term. They're dependent. They're dependent on what you just found to find the next one. Right? We talked about that. What we're talking about today is independent. It doesn't call on a previous term. You don't have to know the 82nd term to find the 83rd term in explicit formulas. Explicit formulas will, it'll be what we're going to write later. There's 2 types of explicit formulas that we're going to focus in on. One is called arithmetic, and one is called geometric. We're going to talk about those in a couple of days, and we're going to write equations for them. Now, the beauty of those equations is you follow a formula, you write the equation, it's easy. Today, it's going to be a little harder because we're going to try to think outside the box again, kind of like you did on number 6 with the explicit formulas we're doing today. But the place that we're going with these formulas is way better. In fact, these fit that category that Jacob asked about a second ago. Because they stand alone, because they're independent, you can write them as a function. In fact, here is the definition of an explicit formula. It is a rule in which the nth term, y'all know what I mean by the nth term, right? If I want to find a sub n, any term, a sub 12, a sub 27, if I want to find the nth term, it is defined as a function of n. In layman's terms, here's what this means. It means if I want to find the 6th term, do I need the 5th one? Nope. If I want to find the 6th term, guess what I do?
You apply 6 to the formula.
I plug 6 in, right into the formula. If I want to find the 83rd term, like I said a minute ago, I don't need the 82nd one. If I want to find the 83rd term, I type 83 right into my function, right into the equation that we're going to come up with. If I want to find the 100th term, I plug 100 right into the function. It's independent. I don't need to know previous terms. So think about this, guys. If I don't need to know previous terms, what won't be in the equation like the recursive equation had? What won't be in it? A sub 1, we don't have to tell them, right? We don't have to tell them the first term. They don't need it. If I want to know the first term, what do I get to do? Plug in 1. What else will I not have in the equation? I won't have the a sub n minus 1. I don't need to call on a previous term. Instead of having a sub n minus 1, what will it have in the equation? Nuh-uh. In the equation. It'll just have n. Right? It'll just have n. Why? Because all we got to do is plug in the term number to find the term value. So for example, and I'm going to show you this first one, and then I'm going to show you why explicit formulas are so much nicer. And Jacob has already kind of told you this. But I'm going to show you the first way first, and then I'm going to show you the easy way, the one I expect you to use from this point forward with explicit formulas when they ask you to find the first 5 terms. Okay? Here's how you do it. To find the first 5 terms, to find the first term, I plug 1 directly into n. What is 1 minus 3? And what's negative 2 times 7? So what is my first term's value? Negative 14. What will I do if I want to find the second term, y'all? I plug in 2. 2 minus 3 is? Negative 1. Negative 1 times 7? That's my second term's value. What will I do if I want to find the third term? 3 minus 3 is? 0 times 7? 0. Now, I know most of you guys, y'all see the pattern at this point, right? What's happening every time? It's going up 7, isn't it? It's rising 7. But I'm going to keep this going. If I want to find the fourth term, I plug in 4. 4 minus 3 is 1. 1 times 7 is 7. If I want to find the final term, the fifth term, 5 minus 3 is? 2 times 7 is? My first 5 terms are negative 14, negative 7, 0, 7, and 14. Now, that's great and all, and it's not even hard. But because of what Jacob said a minute ago, I don't have to go through all that trouble. Because when it's a function, how can I find my 5 terms faster? I can go to my calculator. I can go to where I plug in functions. Where do I plug in functions? Y equals. I can type this thing right in, just like I see it, except instead of n, I put a what? I put an x. And then I can, do I need to graph it? No, what do I really care about? I care about my table. Because remember what I showed you on the front side of this note sheet? Every term in a sequence is identified by 2 numbers. The term number and the term value. So if I look at the table, what term number do I care about first? Term number 1. Remember? Counting numbers. And sure enough, what is term number 1's value? That's exactly what we said, right? Negative 7, 0, 7, 14. See? The beauty of explicit formulas is you don't have to rely on a previous term to find the next term. You can go to your calculator, you can type it in as a function in y equals, and then you can look at your table and you know all of your terms. Okay? So I'm going to do that with number 9, 10, and 11. So number 9, go to y equals, clear that one out. And we're going to type in, just like we see it, negative 4, and instead of n, x squared. I don't care anything about the graph. All I care about is the what, Hunter? So I go second graph. I go to my first term. And what is the value? Negative 4 is my first term. What about my second term? Third term? Fourth term? And then finally my fifth term. That's done. I'm writing it on my paper. I'll put them back up in a second for you guys who aren't following along. Let's go to y equals. And I'm going to do number 10 now. Don't ever ask me how to do this later. I will slap you in the nose. So we got 2 times x, open parenthesis, x plus 5. I don't care anything about the graph. I care only about the table. And what's my first term's value? 12. Second term. 28. Third term. 48. Fourth term. And fifth term. See how easy this is? So I'll do the last one I'm going to do, and that's number 11. Open parenthesis, negative 2. Close parenthesis, raised to the x minus 1 power. I'm going to go to my table. I'm going to scroll to my first term, and what is it? Second term. Third term. Fourth term. Negative 8. And finally, fifth term, 16. All right, so if you didn't write those down, as we were doing, there they are. Okay, I did 4 of them. You're going to have 4 of those in your homework. But if you look at numbers 7, 8, 9, and 10, those should take, what, 30 seconds to do them? Yeah? That's half your homework assignment. Now, here's the last half, the more challenging half. And you have to think differently than we did with recursive formulas. Okay? So you got to think differently. So let me show you number 13. And I want you to write this. I want you to think differently. Here's what we did with recursion. Didn't we have to state the first term? And then it was all about what am I doing to that previous term, right? So y'all look at this. What's happening from -7 to -9? Subtracting 2. What's happening from -9 to -11? Subtracting 2. So every time it's taking the previous value and subtracting 2. Now, what do we name the previous term? And then we subtract 2. That was recursive. That's how we thought through recursive. You've got to change your line of thinking for explicit. Let me explain. If y'all wrote that, I'm sorry. That was recursive. I'm showing you explicit. I want you to see the difference. You see, I'm not talking about what did I do to -7 to get to -9, and what did I do to -9 to get to -11. I'm not thinking that way. I'm thinking, what did I do to 1 to get -7? Right? I got to plug in my term number to get my term value. So I'm thinking now, what do I do to 1 to get to -7? So maybe I take 1 and I'll call it in, term number, and maybe I subtract 8. Doesn't 1 minus 8 equal -7? So let's see if that works for the second term. What do I plug in if I want to know the second term? I plug in 2. What's 2 minus 8? Not -9, right? So it's not, unfortunately, as simple as subtracting 8. Good try, but it's not quite that simple. So you start thinking about some things that you see. Like, for example, the fact that every term it is dropping 2, right? What can you do to a term where every time it does drop 2? What is that? So if I subtracted 2 every time, okay? If I subtracted 2 every time, what would I need to do to end to plug 1 in and it end up giving me a -7 out? You said subtract 2, so I've got to subtract 2. So what would I do to 1 to get me in a position, if I subtracted 2, it would cause it to be -7? Think about it. To subtract -2 from it to get to -7, what would it need to be? -5. What could I do to n to make it equal -5? No, you already did subtracting. What else could I do to n to make it equal -5? Think. Couldn't I multiply by -5? -5 times 1? What's -5 times 1? What's -5 minus 2? That got it there, didn't it? Let's try term 2. What's -5 times 2? -10. What's -10 minus 2? Not -9. Not -9. So I can't just subtract 2 from something. What do you want to try? We got to think outside the box. This is why this is a little hard. It'll be easier when we deal with arithmetic and geometric sequences because you just get to follow a formula. Multiply what by negative? N? By what? Negative what? -2? Okay, let's try that. So let's just try to multiply by -2. That kind of makes sense, doesn't it? Because what is 1 times -2? And what's 2 times -2? How far are those away from each other? That's getting you that gap of 2, right? So look, if I took first term, y'all got it. If I took the first term, I plug in 1, right? What's -2 times 1? And how do you get from -2 to -7? You subtract 5 more. That gets my first term. Let's see if that gets my second term. Plug in 2. What's -2 times 2? What's -4 minus 5? Hey, we might be onto something. Let's try one more. Usually if it works for 3 of them, it works for all of them. What's -2 times 3? What's -6 minus 5? Boom, we got it. My explicit formula is -2n minus 5. So a sub n equals -2n minus 5. Now, that is an arithmetic sequence. In 2 days, or 3 if we get out tomorrow, we will learn the equation that will let me consistently come up with that equation, okay? But not today. Y'all had to just wing it, and it was fun, right? Kind of challenging. Okay, look at 14. Remember, you got to think differently. To get 3, I plug what into an equation? To get 6, I plug what into that same equation? To get 11, I plug what into that same equation? That's how you got to think. I got to come up with an equation that when I plug 1 into it, it gives me out what? 3. When I plug 2 into it, it gives me out what? That's how I got to think. So, what are some things you notice about your numbers here? Is it changing consistently like the last one did? No, in fact, to get from 3 to 6, I went up how many? 3. But to go from 6 to 11, I went up 5. To go from 11 to 18, I went up 7. You notice something? Every time it's getting how many more bigger? It went from 3 to 5 to 7 to 9. What's happening? Every time it's getting 2 bigger, isn't it? Can y'all think of something that you could do to a number that every time it's going to get 2 bigger? What's compound mean? Can I just multiply it by something consistent like I did in the last problem? No, that won't make it 2 bigger every time. You could try an exponent. What exponent you want to try? What's the first exponent? Squared? Let's try that. So let's plug 1 into that. What's 1 squared? But I got to get it up to where? How would I get 1 squared? 1 up to 3. Add 2. All right, so that'll get me to the first term. Let's try the second one. Plug in what? 2. What's 2 squared? 4 plus 2. Does that match? Let's try the third term. Plug in 3. What's 3 squared? 9 plus 2. Got it. Our equation for a sub n is n squared plus 2. What do y'all think? That's not too bad, right? That would be geometric. Actually, it's not geometric. No, this would be just random. Yeah. Geometric would be you're multiplying by something consistently every time. Multiplying by 3, multiplying by 3, multiplying by 3. For these? Nah, we won't graph these. Do you want to see the graphs? No, we won't look at the graphs. All right, let's look at 15 and 16. Remember, how do I get 2? I have an equation, and I plug what into it? 1. I plug 1 into an equation, and it'll give me a 2 out. What do I plug in to get 5 halves? 2, 3, 4, 5. I need an equation that I can plug those numbers into, and it gives me those in return. Now think outside the box a little bit. What do you see happening every other problem? Every other term? It's growing by 1/2 every time. So what you basically have is 4 halves, 2. Then it goes to 5 halves. Then it goes to 6 halves. Then 7 halves. and then 8 halves. So with that being said, what's the denominator every time? Every time my denominator is 2, right? Now, how's the top changing? Well, remember, the very first term is key.
Well, it's changing by 1, so it's changing the rate of. It's changing by the rate of the numbers, like increasing by 1. So all you have to do is match up the first one.
Okay.
By adding 2. Wait, no, by adding 3. And probably line up with all.
Let's see. Let's see. He thought about it a little differently than I did. Here's how I thought about it. Remember what we have to plug in to find the first term? What do we have to plug in to find the first term? But yeah, we got to plug what into n? We got to plug 1 in to find the first term, right? So think about this. If I plug 1 into the n, what would I need to do on the top? So that value would divide by 2 to give me 2. What do? You got a couple options. What would I do to n where the top would end up giving me a 4? Because 4 divided by 2 equals 2. What are some of my options? Adding 1 will only get 1 plus 1 to 2. And 2 over 2 is just 1. So maybe we add 3. What's 1 plus 3?
4.
What's 4 divided by 2? Would that give me my first term's value? Let's try the second term. Plug in 2. What's 2 plus 3? Will 5 over 2 give me 5 over 2? Let's plug in the third term. 3 plus 3? 6 divided by 2 give me 3? There it is. A sub n equals n plus 3 over 2. These are a little tricky, guys. You got to think a little bit outside the box. Now, really, the 16th number, the last one, is the easiest one. Because think about it. To get 1, don't I plug 1 in? To get 2, to get square root 2, I put 2 in. And then to get square root 3, I get 3 in. And then 4, and then 5. So what do most of these problems have in them? So my equation is probably going to have a square root in it. What do you think? So you think it's just square root of n. Well, let's try it. What's the square root of first term? 1. Does that match? Does the square root of second term 2 give me square root 2? Square root of 3 give me square root of 3? So sure enough, it's just a sub n equals square root of n. So that one actually wasn't too bad. But the point I need you guys to understand is the fact that these you have to think a little differently than the way you thought about recursive. Recursive, it's all about, hey, what did I do to the last term to get the next one? But with explicit, you think, hey, what do I do to the term number to get the term value? So your homework is to finish up 7 through 14. Tomorrow, I will check, and your grade will be based on numbers 1 through 14. Y'all did 1 through 6 last night. Everyone should have those done. So now all you got to do 7 through 14. 7, 8, 9, and 10 should take 2 seconds if you use your graphing calculator like you should. And then that leaves the last 4 to be a little more challenging for you. So those are the ones where you're probably going to have to spend your time.